Okay.
Can you hear me? There we go.
So we are doing this online. So. All right. I'm not going to step on that, which is normally not there. First thing I do on live stream, let's face plant. Sounds like a good plan. So welcome. While all our live viewers are coming on, welcome to United Astronomy Clubs of New Jersey. We do live programs on site from April through October, starting at 8 p.m. So just a few things. When you are coming in, watch for pedestrians because no one likes getting run over. When you leave, use your headlights because even though light gets annoying at night, being run over is far more annoying. If you need to use the bathroom, we do have the public restroom, which is the porta potty right over there. We also have a little gift shop should you choose, and all the donations from the gift shop do get put towards offering more public outreach and free public programs. So, oh, you switched it from the intro slide. Not that many people can see it.
Yeah, that's what I was checking.
But, so we do have stream this live on our YouTube. You can check out our current live stream, and you can also go back and see all our past live streams that we've been doing since the start of COVID. We also have our website, UACNJ.org. That's where we have a list of all our public programs available for the year. I know this one is slightly out of order. There was a scheduling conflict that came up suddenly. So Mark Sproul has nicely decided to give the presentation today and had switched with...
Lonnie, I was supposed to be next week. Lonnie was supposed to be this week. We just swapped.
Oh yeah, it is the first weekend of the month. Normally we have the What's Up in the Sky on the first weekend of the month. How time flies. So, Mark Sproul has a computer engineering degree from Rutgers and has a master's degree in mechanical engineering from Stevens. He got his start in astronomy in the 1990s writing image processing software to read NASA Voyager images. He specializes in embedded computer systems and image processing. And tonight he's talking about the observatory dome that he built from scratch. So with that, Mark.
Good evening. I'm going to start off showing the little pieces I brought because you can't see the screen quite yet. As any engineer should do, I built a model first. So this is the model of the dome that I built. I didn't realize at the time, it turns out this is Barbie doll scale. So my wife bought me a Barbie doll with a lab coat on it to put inside of here. But this dome taught me a whole lot in building it on how to avoid pitfalls. Now, how do you build a big dome like this? Well, you just have to have the ambition and start. What is plywood but layers of wood? And we're going to see some pictures on this presentation, but right now you can't see anything. I cut arc segments of wood out of just standard plywood from Home Depot. And plywood is nothing more than layers of wood glued together. So I took them, two of those pieces, multiple of these pieces, and I staggered them like that and glued them and screwed them together to make my big arc segments, which looks like this. And you can't see, of course, from here, but if you look at this, you cannot find the seam. It is so well done. I use Gorilla Glue, and everybody uses Gorilla Glue. Really strong stuff. You can't even find the seam, and really, really strong. This happened to be one I broke because I fell on it. And
Like I almost did?
yeah, like you almost did. And this is an actual piece that I made for demonstrations of what it looks like. This is real size of the dome. The only thing about it is, for my dome, this part down here, the footer sits, let's not fall over, at this level. So the top of the dome is 13.5 feet up in the air. Now, a lot of our telescopes here you can look through with eyepieces. The primary eyepiece on my telescope, if you wanted to look through it, you would have to be on a ladder 13 feet tall, climb up a 13-foot tall ladder. So my observatory is all computerized, all automated, and I run it entirely from my basement without even having to go out there. And I wrote all the software, but that's a whole nother lecture beyond the scope of tonight's lecture, but that's what I do. That's how I got it started in astronomy, was writing software. Now, can you see this at all? No, you can't. Let's take a look at the next one. All right, we already went over that. Background inspiration. So in 1999, I tried to build an observatory where I used to live in New Jersey. You cannot see that, can you? You can't see that at all. Anyway, it's a garage, and it's got roofs that slide open. And the problem with it, when it was closed, you couldn't stand up. And I never finished it. And 7 years ago, 8 years ago, 7 years ago, we moved to Pennsylvania. And my good friend and astronomy mentor talked me into doing something because I moved to dark skies. So I found this online. Can you see that?
I will say, like I said, we are streaming it, and all our videos are available on our YouTube. So if you want to go back and see any of the slides, a great way is through our YouTube.
So I found this guy had done this, a 24-foot wooden dome using the wooden thing. So I got some inspiration, and that's what I decided to build. And you still can't see that. Oh no, God, that's so. So 2015, we broke ground. I built 3 rings. My brother teased me I was building a 3-ring circus. If anybody knows anything about building walls, you have to have a footer, you have to have a header. So I had to have 2 rings for the footer and the header because I was building a round wall. And then the 3rd ring, which would be this piece right here, the bottom of it, is the part that rotates. And it sits on wheels and the whole dome rotates. You see here that all the observatories here at Jenny Jump are roll-off roofs. Roll-off roofs are cheaper, easier to build, and they have their advantages, but so do domes. For public outreach, roll-off roofs are far better. For remote operation, a dome is much better. Better protection from the wind, better protection from stray light. So there's pros and cons, and I chose to go with the dome. A lot more work. So in January of 2016, I started the dome construction. It took me 2.5 years to build this dome. I built it from scratch by hand. We got a lot of pictures coming up showing it, if we can see them. And it took me 30 hours a week, every week for 2.5 years to build it. Uh, 15-foot diameter, wood rims, aluminum skin. Almost everything in the dome was purchased at Home Depot. With a very few exceptions, Home Depot. When we were all done, we went back and added up the Home Depot receipts. You don't want to know how much it came to. And so this aluminum skin is roofing flashing, which you would have on your roof for joints in a roofing flashing. Still can't see that, can you? All right, maybe we can see it. All right. So I had a contractor build the garage. Built the foundation, the concrete, the walls. No paint, no insulation, no electrical, just a frame to my design and the half of the second story. So the bottom is a standard 24 by 24 foot garage. Doesn't have any garage doors, but it's that size, which you would normally build for a garage. But it has this concrete pillar in the middle. The concrete pillar goes down below ground, below the main foundation, and is separate from this foundation, so that if you walk across the floor, you don't get any vibration. And that main pillar is 4.5 tons of concrete just in that pillar. And it goes up to about this high, about 2 feet up in the second story. And then all of the steel of the mount sits on top of that. And I really wish you could see this picture. This is the pillar here. You can't see that, can you? Very good. All right. So that's a concrete pillar. And what you can't see at the very bottom, it's insulation so that there's no physical contact from the floor concrete to the pillar concrete. And then on Thanksgiving Day, so we started November first week of November of 2015. And on Thanksgiving Day of November 15 of 2015, I became King Arthur. Why? Because I built a round table. Can you see that? So the dome is 15 feet diameter. I took plywood, fastened it together on a bunch of sawhorses, and put a router with a pivot in the middle and cut a circle perfectly 15 feet in diameter. And that was my jig for making everything. When you're making something, if you got a jig to make it, I had to make 3 identical rings. Only way to get them identical is have some kind of jig to make it easier to put them together. And that is a very good picture of the table that you cannot see. And then this was a pretty ingenious part. Can you see that one at all? So what I did, I took a 4x8 sheet of plywood, I put a peg in one corner, I put aluminum rod, and I put 2 routers, 2 wood routers on it. Allow me, literally in 10 minutes, to take a 4x8 sheet of plywood and turn it into 10 of these in 10 minutes. Every one perfect, every one exactly the same. And then on that table, laid them out, and what I did was I put wax paper down so it wouldn't stick, screwed them up through the bottom of the table to hold them in place, and then I took the second layer, staggered, like I said before, clamped them together, glued them, screwed them together to make my rings, and then later on to make the exact same construction for the ribs. So as I'm sure you can tell, that takes a lot of time. And that's why it took so long to build. This is also a cool picture. That's a stack from here to here, which is about that tall, of the rib sections. I mean, like I said, I would lay them up on the table, and that went backwards, and glue them. Maybe this one will show. Does that one show any better? Well, there's the person in the picture painting is her, my wife, sitting there painting the picture. So that kind of gives you a perspective of how big it is. When I was done with all of the ribs, stacked them all together, measured them, I had them all perfect within 1/8 of an inch of each other, which is plenty good enough for this type of construction. And what I had, the contractor, I'm sure everybody's heard horror stories about contractors. The contractors I had to work on this garage were fantastic. They built it 100% the way I wanted it built, because I designed it. Of course they had their architecture drawn up, but designed it the way I wanted it to do. I was there. I had every other Friday off, so I was there working beside them every other Friday. And when I said I wanted done something different, they listened to me. They realized I knew what I was talking about. And so we got along really well, really, really great guys. So in the original agreement was, we built the foundation. I needed that floor with no walls on it to build these rings, so I had a flat surface to build it on. And the agreement was, they can't start building the building until I had the 3 rings done. Again, I made 3 of these big 15-foot diameter rings, the footer, the header, and the rotating ring. So then on the first week of December, they started building the walls. And they were done, I think they were completely done by the middle of January. And that one you should be able to see. That is the second, can you see that any good? That is the pillar sticking up through the second floor. And so this is the second floor. This is about 2.5 feet up. That's the pillar that all the telescope's going to sit on. And this is the second floor is not a full second floor. It's only 5.5 feet tall. Not what you would think of a regular building. But again, it was my design, 5.5 feet tall, and then, no, I'm sorry, 6.5 feet. Yeah, the wall was 5.5 feet tall, and then the round wall is 6.5 feet tall that the dome sits on. Then on the 31st of January, with the contractors, the 3 rings I had, we had to lift them up on top of the dome before they finished the 4th wall of the dome. Can you see that? See that? You should be starting to be able to see things halfway decent. And so we lifted it up, used a ladder, Again, these guys were great. We talked about it for an hour and a half about how to do it, listened to anybody's ideas. In the end, they went with the way I suggested, but we listened to everybody's ideas. You guys were fantastic to work with. And we got it all lifted up there without any problems. And then it's up there, and now they finished the dome, finished the building. And this is where I then spent the next 2.5 years working. I worked full time, but again, on top of my 40-hour-a-week job, 30 to 35 hours every week for 2.5 years building it. Underneath a temporary roof on the second floor, I built the dome. One board at a time. You see? All right. So in this picture on the left, there's a blue tarp covering it. Picture on the right, I put plywood on it to support it so the snow wouldn't fall through and everything. And it sat like that, just with a blue tarp over the top of it for 2.5 years while I worked under it. Kept the rain out, kept the snow out, kept the heat in the summertime, but I put an air conditioner in it. And I worked on it up there for 2.5 years. And this is the outside view. That you should be able to see. There's the blue tarp on top of the building. See that any good? So first thing I had to do is I had to work on the rings. Get them all set up, get them, the bottom one screwed to the floor, get it perfectly centered, and built a little tiny 6-inch tall stud walls. Those stud walls would eventually be 6.5 feet tall, but for working on it, just tall enough to be able to work on it. And you can't see them. Can you see them? There's little tiny, let's work. Right there, there's little tiny studs to hold it up that I was working on. And the stairway was put in there, and you can see that ring goes across the stairwell. Well, that's the footer, the bottom one down there, that's the footer that's screwed to the floor. The middle one is the header of the wall, and then the top one is the ring. So the one on the bottom got cut out, but for 2.5 years going up those stairs, I had to crawl underneath there. And it was really strange. Once we lifted the dome up in May of 2018, for 2 days, every time I walked up there, I ducked anyway, even though I didn't have to, just from 2.5 years of doing it. I cut out, in that top section, I cut out holes to put wheels. You put the wheels in upside down, there's a reason for it. If you put the wheels right side up, dirt and bug carcasses and such get in there, and the friction builds up over the years. You put it upside down. So the wheel is on the stationary part, and the dome rides on top of it. You don't get any dirt accumulation. You don't get any friction. It lasts much better, much more engineering choice. Can't see that any good. That one I think you can see. That's the wheel sticking up through there. And there are 12 of those wheels around. Again, this is hand tool, power tools, but tools I bought from Home Depot. Everything's from Home Depot. Okay, it was a big project, but you can do it if you've got the time and the determination. And remember that big King Arthur round table? Well, it became a half round table. I'd made the 3 rings, but now I got to make. So we have 3 big primary rings, and then we have 2 180-degree rings, half circles. And these are the pieces that the door rides on. I didn't make a door for the model, maybe I should, but the door rides on here, so it comes down and closes, and then it's got a motor on it, it opens up, and if you notice, it goes past center so that you can look straight up. So these are very key, and one thing I learned about making the model, that it's a whole lot harder than you realize to keep these perfectly parallel. So as I built it, I put spacers. You see on the back side, there's spacers back here. Those are permanent. As I built it, I put spacers in there in the front side to hold it together to keep it perfectly parallel as I put the rings in. And that really, really paid off. And some of the people up at Stellafane, I entered this in the contest in 2018 and won first place in mechanical. And one of the judges said, yeah, that was a mistake he made when he built his dome. that he didn't do that, so he was impressed that I did. So again, building the model first, I learned a lot. So then, on this half round table, I got to make those arc segments. And those arc segments are a bit different than the regular arc segments because they're not the same radius. They don't pass through the center, so they're a little bit different radius. Had to do all the math, just sines and cosines, used Excel to figure it out. It's not real hard to do as long as you understand basic trig, not real hard. Can you see any good yet? And this is the tip, building the arcs. There's the arc segments, gluing it down. I don't know if you can see, can you see the clamps in there? We're building that. And I sure don't know how I ended up with this picture in there, a clean table. I'm not exactly a clean, neat person, but one day I just happened to have the table clean. But you can see here, it's those main arc pieces for the door actually were 3 layers, 2 layers of one size and a middle layer of a third size to support the door. And this is just a close-up of that. And then we painted them. And I was just talking about the braces between them. Those are all the braces that go between the arc segments for the opening. And then and I had to put a rail for the door to ride on. And I got the door tracks in place. They're up there, they're mounted. I had to build it, get them all spaced properly. And this is a view looking up the stairs. And right here is where I had to duck under for 2.5 years. Scraped my back on it about 2 or 3 times the first week, and then I learned better and got it down flat so I didn't. And I could rotate the dome because it was on the wheels as I worked on it. So this is with it rotated, and you can see all the different spacers in there. So I could rotate it as I worked on it, which became very handy. And then I started building the door. Again, keeping those panels perfectly straight and making sure the door can open and close as you build it was very important. So I decided to build the door first. And I built the door. This is the 2 sides put together. Again, a little bit different radius, a little bit different size, parallel. Put a skin on it, and I got the door moving. In this picture, it's got a white underside. Later on, I changed it to purple, like to match everything else. Why purple? It's her fault. Blame the purple on her. And now this one, I really hope you can see. We have room to spare. Not the clearance between the door and the rafter of my temporary roof was less than 1 inch. I really wished I'd have raised it up a couple more inches, but it fit. And I did a couple times. There were a couple positions as the dome rotated that I couldn't open the door because it would hit the rafters. And that's just another picture of the door. And I just used high density polyethylene plastic, which you can buy on eBay, and sheets of it, and it's not very expensive. Those are my bushings to keep the door centered on the track and keep it sliding nicely, kind of like you would do for drawers to make them slide properly. And then this is and the wheels. What do you use for wheels for this? Can you see the wheel any good? That's the wheel. Got it off eBay with some rollerblade wheels. They got really great bearings. They're really, they're designed to run on pavement and such. And I'm sure not going to be running them very fast. And I use rollerblade wheels. And then you can see the plastic there is the bearing surface that kept it lined up so it didn't get cockeyed. And then we started making the ribs. Same process as the rings, Same diameter as the rings. The two main ones, like I said, were a bit different diameter because they don't pass through the center. But all the rest of them, same diameter, back to my 15-foot diameter. And made a lot. So the cutting table I had, got these two routers on it, and I put a 55-gallon garbage can underneath it to collect the sawdust. That 55-gallon garbage can is full of sawdust. That's how much sawdust I generated. 55 gallons. And back to this is a little bit more detail about how to build the rib. Put wax paper down so it doesn't glue itself to the table. Put the boards down, screw them from underneath with short screws to hold them in place. Put the second layer on. And if anybody's ever used Gorilla Glue, you know it oozes. You see that any good? Anyway, I had this mountains of glue drippings. I'd put down floor covering, layers of masonite wood on the floor to protect the floor. But I had mountains about this high of the glue drippings all the way around. But I was prepared for it, so and as I said earlier, seam what seam. Afterwards, you can come up and look at this. You cannot, it's hard to, the seam that I did is harder to find than the regular seams. That's how well it worked. And I made myself a jig to position the holes. Anybody recognize that pole pattern? Nobody? World War II airplanes? And the ribs are airplanes? 2 reasons. Put them in there. Reduce weight, makes it look sexy. Total of 22 different ribs, and every one of them, all right, now you're starting to be able to see every one of them a different length. One is this long, one is this long, one is that long. Every single one of them is a different length. And you can see that in here. Every one, none of them go up to the center. If the center's right here, if they're all ended here, they'd all be the same length. But every one of them goes in a different location. They're all concentric. If you were to finish drawing them out, they would all meet at the center, but they don't go that far. So every one of them was a different length, and every one of them had a different angle like this. A different angle this way and a different angle this way to make it up to it. Of course, I had to paint them. Had some issues there with it paint sticking properly. Took me a month to get that resolved. First rib installed, that was a big deal, getting the first rib installed. And after that, the ribs kind of started falling in place. And up at the top, it got actually pretty tight. Had a hard time sometimes getting the screw guns in there to get them all screwed up. And I found one thing at Home Depot that I really, really liked. I think it was $79, a laser alignment tool that does horizontal and vertical lines. This is several of them turned on, just taking a picture to show it. Boy, did that laser alignment tool save me time and headaches, getting things lined up. Like I said, $79, this thing, it's got a self-leveling, you just put a couple AA batteries in there, clamp it onto a wall someplace, and it gives you a horizontal line and a vertical line. And use it for getting things lined up, and that's sure. If you see on here,
I figured it out. Can you remove your name tag?
1, 2, 3. These little brackets, they're Home Depot brackets. They cost $1 a piece. There's over 600 of them, but they're what hold the aluminum on the top, hold it all together. And these piece of aluminum on the real one is 4 inches wide. On here it's 2 inches wide. That's to cover the seam so it doesn't leak. But okay, it's $1 bracket. When you have 600 of them, and this is just a picture showing getting them mounted on there. Lots of ribs, lots of brackets. And then I think it was late 2016, Yeah, October 2016, I started putting on the skin. I had to make all the ribs first, had to put them all up in place, and then take them down and put them back up with the ribs on them. Yes. Okay. Okay. Is it going to be my bolo tie? Okay. All right. And the skin is just trim coil. Like I said, it's aluminum flashing from Home Depot. And these are some detailed pictures on how to do. I went one day at a time myself. It took me 9 hours to do the skin on one segment, from point to starting over on the next one. 9 hours to do everything. Come on. There we go. So I have to put the skin up there, I have to draw lines on it, figure it out. And everyone's different. Everyone's a little bit different. So each one had to be fit individually. Get it marked up. This is the 4-inch wide aluminum. That's the one thing I didn't buy at Home Depot because they don't sell it. I had to have a sheet metal shop make those for me because Home Depot doesn't sell. They sell 2-inch wide aluminum strip, but they don't sell 4-inch wide aluminum strip. So that was one of the few things I bought outside of Home Depot. And I had to put that on there. Can't see it, but the holes are already in there for screwing the holes, holding it together. Getting it fitted. Come on. Getting it fitted. Just more of the same. Take it downstairs, cut it with, just shears. They're just great big overgrown scissors, real easy to cut. I went out and bought a fisheye lens so I could get better pictures of it, just because it's so cramped in there you couldn't really get yourself far enough back to take a picture any good. There's more of the same. And then that's the vertical part of the aluminum, showing the bottom of it, the way it fastens on. And I had to put these cross braces in. Again, the laser really helped in getting, that's why they're all perfectly uniform, that you'll see in a picture later. And each one, again, individually cut, compound angles. There's a 5-degree, down angle on each one. I had a belt center so I could get the angles properly. A lot of little details as you built it that you realize, and they weren't hard. None of them were hard to do. Just take a lot of time. So every one of them had a 5-degree down angle plus a compound angle. And you can't see it in the picture on the screen, but the laser's turned on in there. And I don't imagine you can see it. Can you see the laser line in there? Yeah. So right here's the laser line. And I lined that screw up on every one of them and got it to be nice and uniform and looks really cool. Now we get to the pillar. So I got this concrete pillar and it's just rough concrete on it. This is what's called leveling concrete. Again, Home Depot, you mix it up with a certain amount of water and it gives you a perfectly level, smooth surface. And those are the bolts that are going to hold the telescope in place. And again, make a model first. I made a mock-up out of plywood of what my pier is going to look like. And then I designed and drew it up in CAD. And I found a place down by Lancaster? Down the Lancaster area. Wanted to find some place close enough that I could drive to that does water jet. Anybody know what water jet cutting is? Machines that use 100,000 PSI water to cut steel. This place can cut 6-inch solid steel. But they can also cut 20 thousandths aluminum, and I've had them do both, or I've had them cut an inch and a half inch for the pillar. But this was the mock-up. We'll get to some other pictures of it later. But I made the mock-up, figured it all out of how I want it made, the size and everything. Again, make a model first. A cheap model out of plywood, you screw it up, you redo it, versus, what was it, $700 for the steel? I think it was $700. But designed it. I got it cut to size for the same cost it would have cost me to go buy the steel elsewhere. Really was a good deal. And then I didn't want to pay for shipping of 500 pounds of steel. So that's why I picked a place that I could drive to. It was a 2-hour drive, but drove there, picked it up. Really great people to work with. And this is about done. So July 2017. Okay, fast forward. May of 2018. Now the contractors, they built the building, but in my contract, they were responsible for doing the roof, the top roof, the roof of, and they agreed to help me do the raising of the dome. I have a movie of it, but unfortunately it's not playing on this computer, so I can't show it. But we took so the contractors came back, we took the temporary roof off, and then we raised the dome. You can see in this picture, again, I had the owner of the company and the foreman come to my house. We spent 2 hours talking about how we're going to get it raised. At the end of the day, they said they couldn't come up with any better idea than what I already had, and so they went with my route. And what I've got here, you can see, there's these, there, those are U-shaped wood, 2x6 with a plywood back on it, screwed to the floor and braced to the wall. Got the dome sitting down on the ground, stick a 2x4 under it, stick a pry bar under it, raise it up 2 inches, and stick a 2x4 under it. Do that again, stick another 2x4 in it. Do that again, stick another 2x4 in it. When you get 6 2x4s in there, replace it with a cinder block. And you can see there's the wood, because what happens when you get a cinder block over 3 or 4 tall? They get very wobbly. So this U-shaped thing is fastened to the floor, and the cinder blocks are in there. So every time we get up to 5 or 6 2x4s, pull them out and replace with a cinder block. I had enough cinder blocks there, so we raised it up, because we had to raise it 7 feet to be able to then build the wall underneath it and then set it back down. So get it all the way up. You can see it's above that guy's head. It's above, I'm 6'4", and it's above my head. And we started putting in the walls. Again, the contractors there to help me do the wall part, and they did a wonderful job. And then that night, the moon happened to cooperate, and I got my first picture with just a DSLR camera, but I got a picture of the moon through the dome slit that very night. And this is a cool picture. That is looking straight up. I think you can see that I got them pretty well aligned. All right, now back to the pillar. That's my neighbor helping me with it. That's 550 pounds of steel, so I had the steel made, and I found another neighbor that welds for a living, so I paid him to weld it all together. I braced it and built to hold it in place, and he just went and welded it all together, but it weighed 550 pounds. And then I took a whole bunch of wood and made a great big sawhorse, and I built into the floor a trap door. I think it's 4 foot by 2.5 feet trap door, so I can lift things up purposely, so I can lift big heavy things up. So I built this big sawhorse, a gantry crane, and I had a chain hoist, and we lifted up through the trap door. And there we're setting the pillar down onto those bolt holes, and then one side of the pillar has a hole in it, a big, about this big hole, so that you can reach in and fasten everything down, and I have some of the power supplies and such in there. So what's in the dome? Got a German equatorial mount, which is what several of these telescopes are, but the shaft on it is 2.5 inches in diameter. One of the primary shafts, 2.5 inches in diameter, solid steel, weighs 60 pounds. You'll notice that some of these scopes, they have counterweights on them. Well, my scope has 150 pounds of counterweights. When you have a German equatorial mount of this type, you got the scope on one side, you got weights on the other side, you got to get it all balanced out. So I got 150 pounds plus the 60 pounds of the shaft that's just weights. Then I have a 4-inch refractor and a 3-inch refractor on the sides. And then I use Raspberry Pi computers, little computers about the size of a pack of cigarettes, cost $50. and I've got about 10 of them in the observatory running everything. All of them running software that I wrote, but that is a topic of a whole nother discussion, of a whole nother evening that we won't get into. But again, as I said earlier at the beginning of the talk, how I got into astronomy was writing software. That's what I do. I got introduced to computers in 1977 when I was still in high school. Yes, we had computers back then. Within 20 minutes of first being introduced to a computer, I knew that that's what I was going to do. 44 years later, I still love writing software. So this is early on of the telescope. There's the mount, that aluminum, that steel pillar with the primary German equatorial mount on it, and that's with one telescope. That's actually my Cassegrain, which I'm not currently using. And then that's more what it looks like now. Now what we've got is a main 16-inch Newtonian, 16-inch mirror, and then the two little telescopes on the side. Why 3 telescopes on one mount? We're going to see some pictures later on, but different fields of view, different magnifications. And each, again, this is where the eyepiece would go. That is 13 feet up in the air. But I'm a computer guy. My intention was never really to look through it by my eye. It's with cameras. So I've got cameras on all the telescopes. Then this is a guide camera for figuring out a finder camera. It's got a really broad view for finding what you're looking at. This is a close-up of the 3-inch telescope. The 3-inch telescope is only about that long. It's a William Optics W071. I think it goes for $300. It's a small telescope. The focuser I got on it cost 10 times as much as the telescope did. Oh crap. That's a control box. That's a Raspberry Pi. That's a Raspberry Pi. That's stepper motor controllers. That's an Ethernet switch, power supply. That's what controls the majority of the telescope, plus another 4 Raspberry Pis actually on the telescope. This picture I actually took this morning. More what it looks like. This is what the downstairs looks like, all finished up. I even made my own drawers from scratch, built into the wall for holding stuff. This is a picture of the main telescope. This is each one of these weights is 50 pounds, and there's another 20-pound weight there, and that shaft is 60 pounds. 150 pounds of counterweights. This is a picture of the downstairs. Now, when we built this, there was a tree that we had to cut down that was about 100 feet tall and 32 inches in diameter. And there happens to be a sawmill about 5 miles from where I live. So I cut the tree down, had it cut into 12-foot lengths, loaded it up on my flatbed, took it to the sawmill, and they cut it into 12-foot long, 12-inch wide by half-inch thick paneling. You have to let it sit for about a year before you can use it so it dries out. So this is solid oak paneling, not the beam across the top. That's part of but the paneling on the side is solid oak. Who can afford solid oak paneling for a garage? Nobody. I paid $400 to get 4 big logs slabbed into it. Now, I had to do a lot of work. I bought a planer, again from Home Depot for $200. Planed them, sanded them, varnished them, and everything, put them up. It would have been a whole lot quicker and easier to just put wallboard up, but it looks really cool. And it's a tree that was grown right there in the very spot. Okay, so what have I done with it? This is the Orion Nebula. And I forget what telescope that was my big Newtonian telescope I used for that one. It's a black and white picture. We talked earlier about field of view, the 3 different telescopes. Why do I have 3 different telescopes? Well, some things are really big, some things are really small. None of my current telescopes are any good for planets because they're too small. But for big things, like this one, this is the Andromeda galaxy. That is 7 times the size of the full moon. My big telescope, the full moon doesn't even fit in it because it's got too much magnification. This was taken with my smallest telescope. So it's then that is 2.3 million light years away. That's the closest galaxy we can see in the northern hemisphere. But I took that with my scope. With the other telescope, the Cassegrain, I did do some planetary work, but I don't have that one currently mounted. Picture I did of Jupiter, and you can see down there in the right corner 2 of the moons. You can't see those, can't you? And of course, the moon. And this is a really good picture of 2, not the smallest one, but the middle one and the big one, taken the same night of the moon, a full field of view. So that's the field of view of my middle telescope, and at the exact same time, that's the field of view of the big telescope. So that's why I have the different telescopes, so I can, without having to change anything, and in this case, do them at the same time. What's left? I just got to finish the downstairs. I got a little bit more ceiling work to do, a little bit more insulation work to do, and then I got to clean it all up and put my machines in there. I got a milling machine and a lathe and such, and I'm going to build an optical bench and put in a computer desk and such like that. And I've been working on this pretty much nonstop since 2015, and I'm still going, and I'm still loving it, and just keep on doing new projects. And now, tomorrow morning, I got a big RV and I got a great big flatbed trailer. Tomorrow morning I leave for Barra College in Barra, Kentucky. This building at this college is being torn down. And there's a large telescope on the top of it with a dome my dome is 15 feet. It's 14.5 feet diameter, so it's almost the same size really. It's a commercial dome called Ash Dome. And a guy that went to school there talked the university into saving it. Somebody else is getting the telescope, and I'm getting the dome for free. I got to go get it. I got to help. They're hiring a crane to pick it up and set it on the ground, and then pull the telescope out and set it on the ground. The guy that's getting the telescope is getting shipped to Canada, and I'm getting the dome and going to bring that home and figure out what to do with it later. So I always got projects. And I am ready for questions.
All right, so before we do a Q&A session, I'm going to carefully step around like I didn't do when we started.
What's that up there?
Do you want to actually go back to the start and possibly show the beginning pictures to our live audience? Because unfortunately, the closest star, the sun, is very bright and it washes out our current setup. We have been trying to continually improve since COVID started, and we started live streaming. So unfortunately, we're limited by what technology we have and has been donated, and we've acquired through donations from the public. So
this is the observatory I built in 1999 in my house in New Jersey. You see these aluminum roofs, they slide off, and when it's closed, you can't even stand up upstairs, and I never finished it. This is the design I found on the internet that gave me the inspiration about how to design mine. He cut his out on a bandsaw. My innovation was using the routers on the table. I was able to cut, like I said, 10 of those, and one sheet of plywood reduced to 10 of those in less than 10 minutes. And this was his finished dome, 24 foot. And I figured if it's going to work for a 24-foot dome, it sure as heck's going to work for a 15-foot dome. Timeline. This is the foundation. Those are the footers. The 4 around the sides are holding the main pillars where the big beams are. And the one in the center, you can see it's lower. That's going to hold the pillar. And I really like this picture that shows the pillar and shows the insulation around there. That's just foam insulation. So there's no mechanical connection between the floor and the pillar. Again, that pillar is 4.5 tons of concrete. At least that's what they told me. And I went the wrong direction. And there's my King Arthur picture, my round table. And there you can see the aluminum arm with the router on the end of it. And you've all taken a compass and drawn a circle. Well, you get a perfect circle. Well, I got a perfect round table. And this is the cutting table that's still in the garage for cutting the ribs. The holes in it are so the sawdust had someplace to fall down, and the trash can was underneath there. And there's a stack of the arc segments. And there's gluing it together. Again, just Gorilla Glue, globs of great globs of Gorilla Glue. Say that 3 times fast. And a ring. And like I said, everyone came out pretty much perfect. I did have to do a little bit of sanding on some of them to get them all down 1/8 of an inch, but not very much. And there's my wife painting one of them. Again, I include this in here so you get a perspective of size.
No banana for scale?
This
people got it.
This, again, I took a center post and clamped that to that and said, I got to be able to take this and run it all the way around without it. And I just run it around until it hit, and I'd sand that part down and just keep on going. So I could run this all the way around. And, I got it all pretty much perfect. The walls. This is one of the other pictures I really wanted you to see. There's that pillar sticking up through the top. This is getting ready to raise the rings, pushing them up the ladder. This was the key point. This was when it was just tilting over from being weight on top to weight on bottom. The rings are up, and then that same day they then finished because we left one wall open so we could get them up there, and then that same day they finished that wall. This is about the point where you can start to see, right? All right, I think we're probably far enough along. You ready for questions?
Right. So we do I'm not going to go back there because I'm going to risk tripping over something again. So we do a Q&A session at the end. You can... Hello? Hold on. Hello? Okay. Better? All right. Now that we can hear me, I mean, I can yell, but then online people can't hear me. So, we do have questions online coming in. While I have those questions coming in, for those people who perhaps got here a little late, I will go over a couple things. We do have the porta potty for you to use if you need to use the bathroom. We do have the sales desk that all proceeds go to keeping our lights on, keeping us offering free public programs, and continually upgrading our setup so that we can offer you a better experience. We are a Did I say that?
No, you didn't.
I'm like a goldfish. Occasionally I get around to the opposite side of my tank and forget where I am. So we are a nonprofit, so everyone you see here today is a volunteer. To my left, your right, we do have all the observatories, which are the shed buildings you see with the roll-off roofs. We do have several open currently, and right now it's a little light. My needing distance glasses eyes can't see anything currently.
Nope.
But they might be able to have something up. I don't know what they might have up, but you can go over there and check it out. So, for our live audience, when you leave, please use your headlights because we don't like running people over. It hurts, and that's just a bad time for everyone. If you need to use a flashlight or a light to walk around, please keep it pointed down towards the ground. It just prevents us from shining it in one another eye and blinding us. We can't do much about the direction of headlights because that's a built-in feature. Right, so when I come up to you, I will hold the mic for you and you'll speak into the mic so our online audience can hear the question. And I'm going to start off with one of the questions from online. Early in your presentation, you mentioned that your settings are automated. Can you elaborate on the type of automation you have run to the telescope?
It's not actually automation, it's remote operation. I'm using software that I wrote running the Alpaca protocol, which is a offshoot of the ASCOM protocol, which has been around for 20 years in astronomy stuff. And it's all remote operation. It's not automatic yet. But I sit downstairs where it's nice and cool, and I can do everything, open the dome, rotate the dome, point the telescope, take the pictures, download the pictures, and close it up at night, and I can do it all in my pajamas.
Right. Is there a question from our live audience? Yeah, I see a hand. Hold on. Let me walk over so our online audience.
So mechanically, how does the door work? How does the door open?
Okay.
Panels, and why doesn't it pump into the ground when it goes all the way full open?
All right, so I'm using a 12-volt truck tarp motor that you put on dump trucks, and it drives a chain, which drives a sprocket, and then I have magnetic door sensors, like you'd have on a window for an alarm, to know where the door is, and I use a little microprocessor called an Arduino to turn on the motors, ramp them up, ramp the speed up, sense where they are, stop it when necessary, and then I can send it commands all remotely to do a same thing for the dome rotation, using the exact same motor, the exact same sprocket mechanism that is got around the inside, drives a sprocket, and uses computer control and sensors so it knows where the dome is. No, I actually have a really good picture of that, so let me just find them here. I'm using rollerblade wheels that run on just a piece of aluminum that is fastened to the side of the main arcs. There we go. There's a picture that we couldn't see before. So this is high density polyethylene. This is a guide to keep it from getting skewed up. This is a rollerblade wheel just stuck to a screw. And on the sides of these pieces, I put L brackets and a strip of aluminum for those wheels to ride on. And they're on the outside, and the sprockets are on the inside, so they're protected from the rain, and it drives it that way. So basically, you know, I looked into getting custom curved garage door stuff, and it was just too expensive. Either couldn't get anybody to do it all, or really expensive to get it to the right curve, and I just built it myself.
All right, so we have another online question. You have 3 telescopes. What's the difference between them?
Focal length. Each one of them has different magnification, so different field of view. So I can take a high resolution picture, a high magnification picture of the moon. At the same time, I can take a picture of the moon that shows the whole thing. The picture of Andromeda that I showed only will fit in the smallest telescope because I've got a really wide field of view. If I were to try to take a picture of Andromeda with the big telescope, you'd get the little tiny center of it and really not see anything. So it's all about field of view and magnification.
All right, is there another question from our live audience? Hold on, let me run over.
Hi, did you say that the 4.5-ton concrete pier was sitting on styrofoam?
No. The styrofoam is the insulation on the sides to isolate it from the floor. It's got its own heavy-duty 4 foot by 4 foot by I don't know how deep footer underneath it. The styrofoam insulation is mechanical and thermal insulation from the rest of the floor in the horizontal direction.
All right, is there another question from our live audience? Bueller? Nada? I actually have one question. Is there one step of the process that you particularly hated and what just was like, oh, I just got to get this over with?
Carol, can you answer that? What did I hate? What part did I hate? I don't remember hating anything. There's a couple minor things I would have done differently, but just they're minor. Would I do it again? When I originally started, I was expecting it to take me a year to do it. Ended up to build the dome. It ended up taking me 2.5 years. Would I do it over knowing what I know now? Yes. I'm really proud of it. I really enjoy it. It is working perfectly. The only problem I have on it is if it's windy and raining, I get some leaks. That's the only issue I have. Everything else is working just the way I wanted to. The gentleman back in the back asked about the door opening. I got a motor with a sprocket on it going to a bigger sprocket, and I put 2 chains on it, 2 sprockets, 2 chains. And why did I do that? In case one breaks, the door doesn't go slamming. And I've had one of those chains. They're little tiny bicycle chains. They're called code 25 chain that you get from an for car. I should have probably gone with one size bigger chain. So I've had that break twice. So that was good engineering that I'd put a backup in there. So when the chain breaks, there's a second chain, and okay, now go up there and replace it. And I do have a ladder that allows me to safely get all the way to the top and work on it.
All right. So it looks like the questions from our online audience have come to a stop. Were there any last minute questions? All right. I want to thank everyone for coming out. I'm not going to walk near the speaker with the microphone because that's just pain for everyone.
The one question I expected that nobody's asked yet is how much did it cost?
I think we all know that it was quite a bit.
I think I haven't kept real accurate track, but it's between 80,000 and 100,000.
So we could buy a new home for the price you spent on.
Well, it is a new home. It's a complete building, a foundation. I bought the biggest electrical panel Home Depot sells, and it's full. I used 700 feet of Ethernet cable wiring it. I don't use wireless, it's everything wired.
So at that point, the question is, are you renting it out to make some money back?
It has no bathroom.
Oh, well, that's a deal breaker right there.
Well, I'm an hour north of here in Pennsylvania, up real close to where New Jersey, New York, and Pennsylvania meet. I'm out in the country. My skies are a little bit darker than they are here. On a good night, I can see in the center of Andromeda with my naked eye. So for the East Coast, I've really got good. It's worthwhile. It was worth doing it as dark as it is up there.
Right. So I want to thank everyone for coming here to our live presentation. I want to thank our online audience for tuning in on our YouTube. So if anyone ever wants to come up but somehow misses a reservation, we do stream it online, so you can always catch it that way. If for whatever reason you can't make it, you can still catch it. And I believe we actually just upped our reservation limits. We have been very blessed with volunteers who have come and allowed us to up the limit to safely allow you guys to come up. And I thank you guys for social distancing and all that. Even though I am fully vaccinated, I'm choosing to wear a mask because I have too many at-risk people at home, and we are mask optional currently. So as we're following the New Jersey state guidelines and the CDC guidelines, where if you're outside and you're social distancing, I believe it says, you can remain maskless, and as long as you are vaccinated indoors, we're being clacked on it. Our online audience thanks you. I'm going to put chat down so I can focus. You can check us out on our website, UACNJ.org. We are also on Facebook, Instagram, Twitter. I'm sure I'm forgetting one, and someone's going to yell at me after stream for that. And I wish you all a good night.
I'll be around for more questions if you've got them.